Next chapter of the paper is complex numbers. The definition of complex number, the number of the form z is equal to, z is the notation for the complex number, x plus iy, the number of this form. What are x and y? X and y are real number. That is x maybe in point, or x and y maybe in point or fractional number, negative number, positive number, maybe integers. And what is I? I is root minus 1. Means I square is what? Minus 1. Is called a complex number. The number of these forms, x plus iy, are called complex numbers. What are x and y? X and y are real number. For example, 3 plus 2i, 4 minus 5i, minus 6 plus 9i. That is, these x and y uh, are positive, both are positive, negative, all combinations. Then 1.2 minus 3 by 4i, that is, this y is now a fractional number. This x is in the point 1.2. So this is also complex number. Then 3 is already actually the natural number or integer, but it is a real number. It is also a real number, but we can express 3 in the form 3 plus 0i. That is, it is a complex number. So all integers, all real numbers are complex numbers. zero point 0.5 is a purely real number, but it is also a complex number. We can write 0.5 as 0.5 plus 0i. So it's a complex number. So all real numbers are complex number. Obviously, all natural number, all integers are complex numbers. Then 3i. This is the also complex number. We can, because we can write 0 plus 3i in the form 0 plus 3i. So all real numbers are complex numbers. Means all natural numbers, all integers are real numbers. All fractional numbers are real numbers, are complex numbers. The set of all complex numbers is denoted by this letter capital C, and it is what? X plus iy. The number is the set of the elements of the type x plus iy. X and y belongs to R. Or we can write this x plus iy in the form of order pair. That is, we can write in round bracket x comma y. So both the notations are same. That is, either write x plus iy or in round bracket x comma y. That is order pair xy, such that x and y are real number. So the complex number is also defined in as a order pair, in the form of order pair of real numbers. For example, 3 plus 2i, we can write 3 plus 2i in round bracket 3 comma 2. Okay, so 4 minus 5i is 4 minus 5, minus 6 plus 9i is this. So this 1.2 minus 3 by 4i is this. That 1.2 comma minus 3 by 4. 3 number 3. This is a purely real number. Actually, is we can write 3 0. Okay, that is x is 3, y is 0. Then 3i 0 3. Then 0 0 is also a complex number. We can write 0 as 0, order pair 0 0. So if z is equal to ab or z is equal to a plus ib, bi, be complex number, then a is called real part of z, and it is denoted by this notation r, capital R E Z. That is, real part of z is a, and b is called imaginary part of z, and it is denoted by this notation I am z. That is, imaginary part of z is b. For example, if 3 minus 2i, then real part of z is 3 and imaginary part is minus 2. Okay. A complex number whose real part is 0, if the real part of the complex number is 0, then number is called purely imaginary number, such as the number of the form 0i, 0y, that is 0 order pair in the form of 0 order pair 0 comma y, or z is equal to iy. That is, for example, in this 3i is purely complex number. Purely imaginary number. This is called purely imaginary number whose real part is 0. A complex number whose imaginary part is 0 is called a real number, or such a number is are of the form z is equal to x comma y. These are the purely imaginary number whose real part is 0. And if the imaginary part is 0, then that is z is equal to x, or z is equal to x comma y. For example, this number, this 0.5 or 3, whose imaginary part is 0, is called purely real number, and this is called purely imaginary number. Okay, whose real part is 0. A complex number whose both real and imaginary part is 0 is called a zero complex number. For example, this number 0. 0 is expressed in the form order pair 0, comma 0 or 0 plus 0 I. Okay, a set of real numbers can identify as a subset of C. Obviously, R is subset of capital R is subset of C. All real numbers are complex numbers, and the set of complex number is denoted by this notation, either this notation or x plus yi or iy. Okay, and when the two complex numbers are equal, if their real parts are same and imaginary parts are same, so when z1 is equal to z1, z2, if x1 is equal to x2, that is real parts are same and imaginary y1 is equal to y2, and we can denote we can represent the complex number graphically. This 2 plus 3i, that is order pair 2 3, that is the on the x-axis the distance is 2 and on the y-axis the distance is 3. So 2 3, order pair 2 3 is the number 2 plus 3i. Okay, so we can represent a complex number graphically by using this Argon diagram. So algebra of complex number, that is how we can add, subtract, multiply and divide these complex numbers. So z1 is x1 plus iy1 or y1i, right? y1i or iy1. Then z2 is x2 plus iy2. Then addition is the addition of corresponding parts, that is real parts, addition of real part. Here is what is x1 plus iy1 plus x2 plus iy2, that is the addition, is x1 plus x2, that is it is real part of this z1 plus z2, and I y1 plus y2. And subtraction is what? X1 minus x2 and plus I y1 minus y2. This is subtraction, that is the subtraction of real part, subtraction of imaginary part. Very simple addition and subtraction. Then how we can define the product? We can define addition and multiplication in the form of order pair or in the form of this. So this is the example of addition. 2 plus 3i plus minus 6 minus 5i. So 2 minus 6 is minus 4 and 3 and minus 5 becomes minus 2i. Okay, and here subtraction is what? 4 minus 4 minus minus plus 2 becomes plus 2, minus 2, then minus 4 plus 2. Okay, minus 4 plus 2 it becomes minus 2, and this minus plus 3i minus minus plus 5i becomes 8i. This is the subtraction. Then product, how you can define the product of two complex numbers? These are the complex numbers. Then the product of these two bracket, this bracket contains 2 terms, this bracket contains 2 terms, therefore their product contains 4 terms. What are that? x1 into x2, x1 I x1 y2, okay, x1 y2, I y1 x2, okay, and then I x1 y2, and then plus I y1 x2, this term, and then plus I square y1 y2, and I square is minus 1. That's why what do we have? X1 x2 minus y1 y2. This becomes a real part, and then plus like I common from these two. So what we have? x1 y2 plus y1 x2. Okay, so this is the product of two complex numbers. We can also define the product of two complex number in the form of order pair, that x1 x2 minus y1 y2 is the real part, and comma y1 x2 plus x1 y2 is the imaginary part. Then we this is the example of product of two complex number. Minus 4 plus 3i into minus 2 minus 5i is what? Minus minus 2 minus 4 minus 2 become plus 8, then minus 4 minus 5i becomes plus 20i, then 3i into minus 2 becomes minus 6i, and this is minus 15i square. So I square is minus 1, so this becomes plus 15. 8 plus 15, 8 plus 15 becomes 15 and 8. So right here that number 15 is 23, not 38, right here 23. And minus plus 20i minus 6i becomes 49. So right here 23, right here 23 number instead of this 38. Then how we can divide two complex number, that is z1 divided by z2, x1 plus iy1 Then we rationalize the denominator. That is multiply by rationalizing factor of or conjugate factor of this x2 plus I by 2. That is multiply by x2 minus I by 2 divided by x2 minus I by 2. This is called rationalization. And then multiplication of these two brackets is this, that x1 x2 minus I x1 y2 plus I y1 x2, and then last term minus I square y1 y2. And the multiplication of these two is what? You can directly write the multiplication. A plus b into a minus b is a square minus b square. All right, the four terms of this multiplication is what? x1 x2 minus I x2 y2 minus I y2 x2, and then last term minus I square y2 y2. Okay, and then we have the denominator is this is become 0 because plus minus becomes 0, and then x2 square, and this I square is plus is minus 1, so minus minus become plus y2 square, and the numerator is what? x1 x2, and this is plus y1 y2, and this term take I common, then what do we have? Minus x1 y2 plus y1 x2. That is, take this minus sign at the first term, or interchange the first and second term. Also this is divide x2 plus y2 square, x2 square plus y2 square to both terms. We have this. So this is the real part and this is the imaginary part. So in order to divide to complex number, rationalize denominator. This is very important step, that is rationalize denominator. Then it converts the quotient in the form x plus iy. That is in the form of standard complex number. So here is the division of two complex number, 1 plus 2i divided by 1 plus I. That is rationalize the denominator. That is multiply by 1 minus I and divide by 1 minus I. And the multiplication of these two is what? This is the multiplication of these two by using the definition of this multiplication. That is, we get four terms, and then real part is what? 1, and this is plus 2, and then imaginary part is minus I plus 2i. So 3 plus I, the multiplication of these two brackets, and this is 1 square minus I square. That is 1 square plus 1 square. That is 2 minus 1 square I minus I square. I square is minus 1, and so minus 1 become plus. That is plus 2 divided by 2. Okay, so 3 plus I divided by 2, and it is, we can write it is in the form 3 by 2 plus 1/2 I. That is in the form of x plus iy. That is the real part of this number is what? Is 3 by 2, and imaginary part of this number is what? 1/2. So find real and imaginary part. First, obtain the division of this 2 plus I divided by 3 minus 2i. That is rationalized denominator. Multiply by 3 plus 2i divided by 3 plus 2i. That is rationalized denominator. And then multiplication of these two bracket is this. And multiplication of these two bracket is what? X minus y into x plus y is x square minus y square. Actually 2 minus 2i square, but I square is minus 1, so minus minus become plus 1. And then we have this answer, 4 plus 7i divided by 13. That is, this is the that is 4 by 13 plus 7 by 39, but it's square, so 13 square is 169, and then 4 plus 7i square bracket square means 4 plus 7i into 4 plus 7i, and this is what? 4 into 4 16, and this is minus 79, 7 into 7 49. That is plus, and the multiplication. So write the multiplication, we get this. This is the multiplication of these two brackets. We get first 4 terms, then replace I square by minus 1. We have this. So multiply these two brackets by using this procedure. What is the procedure of multiplication of two brackets? This is the first. So we obtain first 4 terms and then replace I square by minus 1. We get the answer. So multiply these two brackets. We get this answer, and therefore this minus 39 divided by 169 and plus 56 divided by 169i. So this is the real part, minus 33 by 169, and imaginary part of the number is what? The number z is what? 56 divided by 169. So reduce the following quantities to a real number. That is obtain the this addition and multiplication, subtraction. Obtain this. We get the real number actually. So we have to find 1 plus 2i divided by 3 minus 4i. That is we have to obtain the division of these two complex number. That is whenever you have to obtain the division of complex number, then rationalize denominator. Very important step. rationalized denominator, that is 3 minus 4i conjugate factor is 3 plus 4i multiplied divided by the same factor. Here is 5 its conjugate factor is minus 5i. Actually 5i is what? 0 plus 5i. So its conjugate factor is what? 0 minus 5i, rationalizing factor. 0 minus 5i, that is minus 5i multiplied and divided by. Because these 2 minus I and divided by 5i both are complex number, and if you have to find division of complex number, then rationalize denominator. And then multiplication of these two term is this, these two bracket. Multiplication of these two bracket is 25, because 9 and plus 16 is 25. And then multiplication of these two is 25 minus 25 I square is minus 1, therefore plus 25, and multiplication of these two bracket is this. And if we find, if we take 25 as LCM, then minus 5 becomes minus 10, and plus 10i and minus 10i becomes 0. So we have the answer minus 10 by 25, that is minus 2 by 5. That is, reduce the following quantities to real number. We have this expression as a real number. Similarly here, so first multiply these three bracket. First multiply any two bracket. We have this answer after multiplication of first two bracket, and then again multiply this two bracket, and then rationalize this 10i. That is, next step is what? I get cancel here. So minus 5 by minus 10 becomes minus 10. So if here is not 5, here is only 5, and then divide by minus 10i, then multiply and divide by 10i. Then 1 minus I raised to 4, that is first multiply 1 minus I into 1 minus I, 1 into 1 minus I 4 times. We get answer minus 1 minus I raised to 4 is obtained as 1 minus I multiplication of 1 minus I 4 times. We get minus 4 answer. Find two complex number whose sum is 4 and whose product is 8. Suppose z is equal to x1 plus iy1 and z2 is equal to x2 plus iy2 be two such numbers that their addition is 4 and multiplication is 8. And then what is z1? Z1 is this, z2 is this, is equal to 4, and z1 into z2 is this. So their addition is this, and the multiplication of these two number is this, x1 x2 minus y1 y2 plus I x1 y2 plus y1 x2 I is equal to 8. And then equating the real and imaginary part. So x1 plus x2 is 4 and y1 plus y2 is 0, because imaginary part 4, the number you can express this 4 as a 4 plus 0 I. So imaginary part is 0. Here is again real part of this number is x1 x2 minus y1 y2 is equal to here 8, and imaginary part x1 y2 plus y1 x2 is equal to 0, because 8 is 8 plus 0 I. And then solving these equations. So first is x1 plus x2 is equal to 4, this y1 plus y2 is equal to 0, and this is the second, and this is the fourth. Solve all these 4 equations and find the values of x1 x2 y1 y2. So from equation number this, we have x1 is 4 minus x2, and then substitute this 4 minus x2 at this place, and from this y1 is minus y2, substitute at this place. We have this equation, and then take y2 as common. So we have y2 in bracket 4 minus x2 plus x2, that is 4 minus x2 minus x2, and that is we have 4 minus 2x2 is equal to 0, and that is y2 is 0, or 4 minus x2 is 0 means x2 is equal to 2. x2 is equal to 2, that is 2x2. 4 minus 2x2 is equal to 0 means x2 is 2. So we have this answer, and substitute y2 as 0 in this equation third, we get x2 in this equation, means we get x2 as a 2 plus minus root 2i, and which is not possible because x2 is real number, and so y2 is 0 is not possible, and so take x2 as 2. So x2 as 2, then we get 3, this equation 3. From equation 3 we get y2 as a plus minus 2. So x2 is 2 and y2 is plus minus 2. Take any either plus 2 or minus 2. And if we substitute this in equation number 1, this equation number 1, x1 is 4 minus x2 and y1 is minus y2, we get these values, x1 is 2, y1 is minus 2. That is, take here plus 2, then we have here minus 2. And therefore the two numbers are 2 minus 2i and 2 plus 2i. Okay. because we have x1, x2. So solve these equations, equation 1 and 2, and by adding and subtracting, and find the values of x1, y1, x2, y2, and we get the answer. Then show that each of the two complex numbers z is equal to plus I and z is 1 plus I and 1 minus I satisfies the equation this. So first take z is equal to 1 plus I satisfies means substitute z as 1 plus I. So 1 plus I square minus 2 into 1 plus I plus 2. Where to show it is equal to 0. And then 1 plus I means directly use x plus y square, that x square plus 2 x into y plus y square, or how we can find 1 plus I bracket square, 1 plus I into 1 plus I. We have this answer 0, and therefore 1 plus I satisfies this equation. Also we can show that 1 minus I also satisfies this equation. Then show that this is equal to 2. That is, multiply these three complex numbers, and these are in the form of order pair. So first multiply any two, suppose first 2, then we have this answer 10, 0, and then multiply these two. Okay, so here is the use this declaration multiplication. Okay, directly write this multiplication is this. Okay, or we can use express this number right here, that 3 plus 1i, this is 3 plus 1i, this is 3 minus I, 1i means 3 plus I, 3 minus I into 1 by 5 plus 1 by 10i, and then answer 2 plus I is the answer. So if you directly find the numbers by expressing this number in the form x plus iy, that is right, 3 plus I, 3 minus I into 1 by 5 plus 1 by 10i, then we have the answer 2 plus I. So complex conjugate, if z is the number x plus iy, then its conjugate is denoted by z bar, and it is x minus yi. Okay, so in the form of order pair, z is suppose order pair xy, then z bar is x comma minus y, is called conjugate. That is 2 plus I, its conjugate is 2 minus I, and vice versa. That is 2 minus I is the number, then its conjugate is 2 plus I conjugate of I is minus I, and so on. So the properties of this conjugate are what? Z is x plus iy, then z bar is x minus iy. If we find z bar, then it is z, it is equal to z bar. So that is, if you find conjugate of this number x minus iy, then it is becomes x plus iy, that is z bar is z. Okay, and therefore z and z bar are conjugate of each other. That is, if 2 plus I, then its conjugate is 2 minus I, and if the number is 2 minus I, then its conjugate is 2 plus I. Z is x plus yi, the complex number, then z bar is x minus yi. Then if we add these two numbers, then we have 2x, that is z plus z bar is 2 times real part of z, or real part of z is what? Z plus z bar divided by 2. Z minus zi becomes 2yi, that is 2i imaginary part of z, that is imaginary part of z is what? Z minus z bar divided by 2i. Z into z bar is what? Multiplication of these two is what? X square minus plus y square, x square plus y square. That is z into z bar is always greater than or equal to 0 quantity, because x square, x, y are real number, and square of real number is always positive quantity, is a non-negative real number, z into z bar. Then 1 by z, that is, how can find 1 by z? That is multiply and divide by z bar, that is z bar divided by z bar, that is division of two complex number, multiply by its conjugate, that is rationalization, x minus yi, then z into z bar is x square plus y square, z into z bar is x square plus y square, x by x square plus y square minus y by y square, x square plus y square, and this is 1 by z. So this is the theorem on the conjugate. Z1 plus Z1 is this, x1 plus iy1, Z2 is this. Then where to prove this and this 4 theorem. Okay, so first one is what? Z1 plus Z2. What is Z1 plus Z2? Is x1 plus x2 plus y1 plus y2i, and its conjugate is what? X1 plus x2 minus y1 plus y2. That is, we have the answer that x1 minus iy1 plus x2 plus minus x2 minus y2 I. Okay, and that is z1 bar plus z2 bar. That is first find z1 plus z2. Z1 plus z2 is this. Z1 plus z2 is what? Take z1 as this. Z1 plus z2 is this. X1 plus x2 in bracket plus I y1 plus y2. And then its bar is what? Then its bar is right here minus sign. Okay, and then we have the x1 minus iy1 in one bracket plus x2 minus iy2 in bracket. That is z1 bar plus z2 bar. That is z1 plus z2 bar is z1 bar. Similar proof of subtraction. Here is the proof of the multiplication is z1 into z2 of multiplication of these two complex number is this, and then its bar is what? Right here just minus sign. It's conjugate z1 into z2 bar. So this is the, and then this is the LHS z1 into z2 bar, z1 into z2 bar, and then RHS is what? Z1 bar into z2 bar is what? X1 minus iy2 z1 bar, x2 minus iy2, and if I find its multiplication is the same, so from 1 and 2 we have this z1 into z2 bar is z1 bar into z2 bar. Similarly, you can prove z1 by z2. First find z1 by z2 is this. This is z1 by z2. Okay. So by rationalizing denominator, we have this answer in the form of x plus iy, and then its conjugate is what? Just right here minus sign. So this is the LHS z1 by z2 bar. The LHS. This is the LHS. Then find RHS. That is z1 bar by z2 bar. So z1 bar is x1 minus iy1. Z2 bar is x2 minus iy2. Then again rationalize the denominator. Then x2 minus iy2 is the conjugate factor is x2 plus iy2 multiply and divide by same. Multiply, and we have the same answer. Here observe 1 and 2, and so from 1 and 2 we have z1 by z2 bar is equal to z1 bar by z2 bar. Okay, so show that this is equal to this number. So first find 1 plus 2I divided by 1 plus I by rationalizing denominator. So we have this answer, and then its fourth power. We have to find its fourth power. So this is 3 plus I raised to fourth power. This is 3 plus I raised to fourth power, and 2 fourth power of 2 is 16. 3 plus I its fourth power. You can find 3 plus I raised to 4. That is 3 plus I 4 times. Multiply 3 plus I into 3 plus I into 3 plus I into 3 plus I 4 times, or directly use the concept that x plus y raised to 4 is what? X raised to 4, 4 into x raised to 3 into y, then 6x square y square plus 4x into y square y cube plus y raised to 4. That is where this term 4 terms by using binomial theorem. Okay, and the answer of the numerator is this 28 plus 96I, because I square is minus 1. I cube, what is the value of I cube? I cube is I square into I square is minus 1, so I cube is what? Minus I, value of I cube. I raised to 4 is what? I square into I square, that is minus 1 into minus 1, that is plus 1, the value is plus 1. And then we have answered this 1 by 4, 7 plus 24I. So what is its conjugate? Then we have to find its conjugate. So what is its conjugate? Just write here minus sign. 1 by 4, 7 minus 24I. So in the next lecture, we will see the definition of modulus and argument.